Okay, we're going to go through part 2 of this AS Core Physics 1 paper from Pearson Edexcel Physics. It's the exam from last summer, so it's the most recent one. It's May 2024, and you can look up on the website, you can search for the grade boundaries if you want to see how well you did. Don't forget to share it with anyone who's doing this exam. I'm starting to add linear papers to the YouTube as well. Before I did mainly international A-level, and it's got quite a large following. So there are fewer students who I know who are doing the linear version. So if you know anyone who's doing it, please do feel free to share the video with them. Okay, so we went through the multiple choice in the first part. If you haven't watched it, go back and have a look. I'll put them all in the same playlist so you can find them easily for ease of reference. Okay, so we went through the first 8 questions, multiple choice. Question 9 is to do with moments and equilibrium. So the first thing you need to know is the windsurfer stands on a windsurf boards and holds on to the sail as shown. As the force of the wind increases, the windsurfer leans back further. Okay, so if he leans back further, he's further from the pivot point. Okay, so the pivot point I have drawn here. Okay, so explain how leaning back further keeps the windsurfer in equilibrium. Your explanation should make reference to moments. Now remember, moments are balanced when clockwise moments are equal to anti-clockwise moments. So clockwise is in this sense, and anti-clockwise is in this sense. Okay? So the clockwise moment comes from the weight. Okay? Now obviously the further back he leans, the further his perpendicular distance to the pivot will be. And if the force is producing the anti-clockwise moment, then if the wind force increases, then its anti-clockwise moment will increase. So you need to make sure that you're explaining it in terms of moments. So that wind force produces an anti-clockwise moment will give you 1 mark, okay? And then the weight of the windsurfer produces a clockwise moment. And if the windsurfer is good, he wants to maintain equilibrium. And that means the sum of the clockwise moments must constantly be equal to the sum of the anti-clockwise moments. So obviously this is a dynamic equilibrium situation because the force of the wind will depend on the direction of the wind and how he's moving his surfboard through the water. So it's going to be constantly changing. So the skill of the windsurfer is constantly trying to maintain the balance by adjusting his position and his distance from the pivot, which I have shown you. Okay? So as the wind force increases, you have to say, as the wind force increases, so does its anti-clockwise moment. So to maintain equilibrium, the surfer leans back more, which increases his clockwise moment by increasing his perpendicular distance to the pivot. That's complete clarity in these 3 bullet points. I haven't left anything to the imagination of the examiner. I have clarity, I have the depth and the detail and the correct terminology. And that's what gets you marks, okay? So all it takes is practicing every single question you can find. So if I gave you papers to do over the holiday and you didn't do them, you should ask yourself, why not? The grade you get will depend on how many hours of practice you put in. And the students who get most proficient at doing these questions will get the highest grades by the end of the summer. It doesn't matter what you got in your GCSE, you're now being measured against a different batch of students. Most students will have got grade 7, 8 or 9 when they've gone into AS level. So you'll be competing against the elite students, okay? That's why it's called advanced. It's no longer GCSE, which G stands for General Certificate of Secondary Education. A is a GCE, which is the advanced level. Okay, so a coin is given a push, question 10, and moves across the table. The coin moves 65 centimeters, so I've clearly shown you that you need to make sure you change the units into meters. So 65 centimeters, automatically I'm putting S as displacement is 0.65 meters. Before coming to rest, that means the final velocity is 0 meters per second. Okay? There is a mean resistive force of given, yes, of F being 2.2 times 10 to the minus 3 newtons as on the coin as it moves. So that's what's slowing it down. Calculate the initial speed of the coin. So you can either work out the acceleration, from the force and the mass which is given to you. So the mass is given to you as 8.5 grams. So if you're one of my students that didn't change it into kilograms, 10 to the minus 3 kilograms, you will lose some of these marks. And once you do that, you then can, because you know A and you know V, you'll be able to use V squared equals U squared plus 2AS. An alternative method is to say that the work done, by the resistive force, F in the equation in the red box, is equal to the loss the loss of kinetic energy. So I've put it in a red box here. And this is known as the work energy theorem. So this method in red, you then put force times distance is equal to half mu squared, and you want to find out what u is because you know m, you know f, you know s. Okay, so once you change the subject of the equation round, you can see that u squared will be equal to 2fs over m, if you know how to do that. And then obviously if you want to find u, you then need to square root that. You'll notice that the 10 to the minus 3's cancel out and will give you a final answer in this method of 0.58 meters per second. I prefer the method in red. I think it's neater. Okay, so as long as you get the final answer to 2 significant figures, because all the data provided is given to 2 significant figures, your final answer should be given to 2 significant figures. Make sure you're using standard form to get used to A-level expectations. Part B, the coin is pushed again with a larger force this time. The coin moves beyond the edge of the table, so it doesn't stop on the table, and falls to the floor through a vertical height of 1.28 meters. So I've immediately put, again, conversion of energy, the loss of potential energy, MGH, will be gain of kinetic energy, which is exactly where V squared equals U squared plus 2AS comes from. So this is why we have an equation called V squared equals U squared plus 2AS. Okay, the M's cancel out, so it doesn't matter what the mass is, as long as we're ignoring air resistance, which we have to in these kinematics equations. It says the speed of the coin as it reaches the edge of the table is 0.40 meters per second. Now, obviously, this is a horizontal speed because it's moving along a table, so you're assuming the table is horizontal. Okay? Calculate the horizontal distance traveled by the coin as it falls to the floor. So obviously, it's going to take a certain amount of time to fall to the floor from 1.2 meters. So first of all, you've got to work out vertically what information you're given, which is in this red box here. So vertically, we want to work out how long it will take. So T is how long will it take to fall 1.2 meters? It's always the same. If we ignore air resistance, A is 9.81, U is 0, and S is 1.2 meters, the height of the table. So once you know that what you're given, you can then use S equals UT plus half AT squared to work out the only missing value, which is T, and therefore T squared will be equal to 2.4 over 9.81, which gives you a time of just under half a second. Okay, So I put it to 3 significant figures as it's an interim value, but you'll notice that all the data again provided is to 2 significant figures. Once you've got the accurate time, you keep the accurate time, and then you know that horizontally there is no change of velocity because we're ignoring air resistance. Put the value in for the initial speed horizontally, which was given to us as 0.40. Multiply by the time we just worked out, yes, and then you can work out that the horizontal distance in that time, it will be able to travel just under 20 centimeters. So I put it in meters, so it's 0.198 to 3 significant figures. You should then round it up to 2 significant figures because that's the accuracy of the data provided in the question. Hope that makes sense. You'll see when you do many of these past papers, and you do as many as possible, and the students who are in the year above you, the ones who are successfully heading towards A grades or thereabouts, have all done every single past paper they can find, and most of them do them twice. Okay? Question 11 continues with mechanics. It says the picture shows a toy car. There is an inflated balloon attached to the car through a pipe somehow. As the balloon deflates, air is released from the back of the balloon, back of the car. So there must be a pipe going through the back of the car, and the car starts to move. Okay, so the air is released by the elasticity of the balloon. The balloon's under pressure, so at the back of the car, air is expelled. I'm assuming there is a hole there, which we can't see, so air is expelled in the red arrow direction. Explain with reference to Newton's laws, so remember there are 3 Newton's laws of motion, how the release of this air from the back of the car causes the car to start to move. Now obviously they haven't told you which direction the car is going to move, but you should be able to tell that the car is going to move forwards. The momentum of the air backwards will equal the momentum of the car forwards. Okay? Now the velocity of the two will not necessarily be equal because they have different masses, but it's irrelevant, I think, to this question. Okay? So the way I've answered it is the balloon attached to the car applies a force to the air. So it's the elasticity of the balloon that's stretched that applies a force to the air once you release the air. So first of all, the air, the balloon creates a force to the air. And by Newton's third law, for every action there must be an equal but opposite reaction. So that means if the air is being pushed backwards, the air applies a force to wherever it's come out of, which is in this case the balloon, which is attached to the car. So the opposite direction is forwards. Okay? So the direction of the green arrow. So that means if you just look at the forces on, so the first Newton's law that we refer to is Newton's third law, action, reaction, it then says there must be a resultant force on the car. So when there's a resultant force on the car, that's Newton's second law where F equals ma. Now Newton's first law and second law are the same, except when it's Newton's first law, the acceleration is 0 because the forces are balanced. So in this case, there is not a balance of forces on the car. The air is pushing it forwards, and therefore the force of the air is greater than any frictional force. So by Newton's second law, you then say F equals ma, the car accelerates from 0 and starts to move. Okay? So starts to move is what we want to say, so it accelerates forwards. That means if it was stationary, it would start to move in that direction. I hope that makes sense. So each of those bullet points is one of those marks. All right, so this is 3 of the short questions done. This is the first electricity question. So we're going to go through this one as well. These are quite short questions at the beginning of the paper. It says a student carried out an experiment to determine the resistivity of a metal alloy. The student used a wire made of the alloy and connected it in a circuit as shown. So you've got a cell in series with the wire and in series with an ammeter, and across the wire is your voltmeter. Now this is actually a core practical resistivity which my students have done. Okay, so you need to know these are practical skills, How did you measure the diameter of the wire when you did it? Yes, so describe how the student could measure the diameter of the wire accurately. Could have measured, I should have read, accurately. So accurately is the second mark. How he could have measured it is obviously with a micrometer. Full name is micrometer screw gauge because it's got its screw that you have to use carefully so you don't produce too much force on it and cause it to have a zero error. And then you should take repeat readings along the wire at different orientations and different positions to be able to get a mean value. Okay, so I fixed my pen, but my pen is charging, so I'm using my finger, which is why my writing is a little bit large. Okay, so this is the first part, 2 marks, practical skills. So you see they can ask questions in this linear exam anywhere they want to. They would accept digital calipers, as the digital calipers also has a resolution of 0.01 millimeters. Now, we bought some digital calipers recently for the school, and we have them, so hopefully you've used them with one of your teachers. But the micrometer is normally the tool you would use for measuring the diameter of a wire. So the exam board are accepting digital calipers. Actually, the mark scheme says digital vernier calipers, which is incorrect. Vernier calipers are not as accurate as digital ones. Digital ones are more modern. Digital ones can be have the same resolution as micrometers, but vernier calipers are only accurate to 0.1 millimeter. Okay? So you need to know that as well for your exam. Part B then says the student made the following measurements. They got the voltmeter reading to 2 decimal places. They got an ammeter reading to 2 decimal places, so 2 or 3 significant figures. So you can tell that what the resistance is, because obviously you're going to need the resistance when you want to look at the resistivity equation, which I put in a circle. And if you just work out the resistance, so before they've asked me anything, I've already worked out the resistance because I know that's what they must be asking for. The diameter of wire is given in millimeters. So you need to change that into meters. So you should use standard form. So 0.58 millimeters is 0.58 times 10 to the minus 3. So why am I doing that? Because you need the diameter to work out the cross-sectional area of the wire, which is pi r squared. But if you're mathematically proficient, you know that's equal to pi d squared over 4, which is a neater way of showing your work. So if you put pi d squared over 4, you'll see that you come up with 2.64 times 10 to the minus 7 meters squared. So really at A level, there's no excuse not to change the units before you put the numbers in. Always use standard form, okay? And the length also, so we now know R, we know A, and they've given us L. Again, L should be given in meters. So now we got everything we need to work out the resistivity. And you just plug the numbers into that equation by changing the subject of the formula to make resistivity the subject on the left-hand side. Put the numbers in. On the right-hand side is what you're working out. On the left-hand side on the left-hand side of the equation is what you're working out. On the right-hand side is how you're working out. If you got all of the 3 numbers in correctly, even if you've taken forward an error, you will show that you have used the equation correctly. And then to 3 significant figures, I've shown you that the resistivity is 1.09 times 10 to the minus 6 ohm meters. But you should really round it up, I think, to 2 significant figures, which I have then done in the space provided for the answer. Hope that makes sense. The student stated that the ammeter reading was the most significant source of uncertainty in the calculated value of resistivity. But you know that resistivity, if we go back to the question above, resistivity has got R, A, and L in it. So the uncertainty for resistivity comes from the uncertainty of the resistance, the uncertainty of the area, and the uncertainty of the length. They have not given the uncertainty of the area, but they're given the uncertainty of the diameter. Okay? So the uncertainty of the area is linked to d squared. So it's going to bring that 0.8% in twice. Okay? So this is the key to this question. Okay? I don't know why that went like that. Let's just get rid of that. So the key to this question is this line. Okay? So the ammeter says 0.9, diameter is 0.8, and the percentage uncertainty in the length was 0.1, so that's not very uncertain, and the percentage uncertainty in the voltmeter reading was 0.3. Okay, so they haven't told us about the, they have, the ammeter reading. So the resistance value will actually be two of them, which contribute to the uncertainty of the resistance value, which is also in the equation. So the resistance value is a combination of voltage and current. So the current brings 0.9%, the voltage brings 0.3%. So you could say the resistance on its own has an uncertainty of 1.2%, but that's not what they're asking. They're asking to assess the validity of the student's statement, where he says that the most significant source of uncertainty in the calculated value of resistivity is the current, okay? The ammeter reading. But the most significant source would be the diameter, as I showed you. Yes, the most significant source would be the diameter, because you need to calculate the cross-sectional area from the diameter, and that's pi d squared over 4, so that's d squared. So the percentage uncertainty of d squared would be twice the percentage uncertainty of d. Yes? So the percentage uncertainty of d squared would actually be 1.6%, which is approximately 2%. Yeah? It's certainly more than the 0.9%. So the student's assessment or statement is incorrect, as 2% is greater than 0.9%. I should really say 1.6%. 1.6% is greater than 0.9%. And that gets you the 9 marks. Hope that makes sense. This is a long question, so I'm going to pause there, take a break, and come back and do the next question in the next video, which is on mechanics. So I hope you found that useful. Once again, don't forget to show your appreciation by liking each video you watch. It helps with the algorithms in YouTube. And share it with anyone who you think will benefit from watching these videos. And make sure you're subscribed if you haven't done so already. If you're my students, you probably already have. Make sure you use the videos. There's plenty of videos in there. And you remember, you can also use the international A-level exams for Unit 1 and Unit 2 will cover your exactly the same content as the first year of the linear AS level exam. Hope you found that useful. Catch you next video. Bye for now.